All right, so we're going to find another example, which is very mathy and not very applicable, but it'll kind of help you see how you can use the various techniques that you use in optimization. A rectangle is inscribed in the portion of the parabola y equals negative x minus 1 squared plus 1 that is above the axis. Find the dimensions of the rectangle with the largest area, and what's the area. So a rectangle is inscribed in the parabola. I graph the parabola here. A rectangle is inscribed means it touches the rectangle. It's inscribed above the x-axis, so it goes right to the x-axis. So this point has to be a point on the parabola, I guess, as does this point over here. But let's see, what do we need to be determined? We need to find the dimensions of the rectangle. So we need to know the base and the height of the rectangle. Now, the height of the rectangle is just y, right? Because that value is just a y value. So that's not hard. But the base is a little trickier. This is the x value. But because we're rectangles, because we're parabolas, this is also x. So this guy's x and this guy's x. And because we know the equation of the parabola, we know that that's 0, and this is 2. And I think you can see my little tick mark for 1 there, and so it's right at 2. So this whole length is 2, and my base is here, and so it's excluding these little x's. So this guy, the base, is 2 minus 2 x's. So that's 2 minus 2 x's. All right. Now, what are our givens? Well, we're given this formula. We're given the rectangle. We kind of drew out our givens in this formula, and we kind of made some secondary formulas already. We knew our base and our height, and we need to find the dimensions of a rectangle with the largest area. So we need to talk about area. Area of a rectangle is base times height. So 2 minus 2x base times height is y. Now, this doesn't help us unless we use our other secondary equation, the equation for the parabola. What does y equal? Well, y equals negative x minus 1 squared plus 1. So we're going to substitute that in. There's always a lot of substituting before you really get going on these problems. Maybe not a lot, but there's some substituting, and I've already made a mistake, so let me erase my plus sign there. All right, plus 1. Now, I find it easier to go ahead and simplify before I start taking derivatives, because if I'm going to maximize, I need to take the derivative. That means I need to go ahead and simplify if I want to make my derivative a little easier. So I'm going to go ahead and do that. 2 minus 2x, and then inside here I'm going to get x squared minus 2x, that's a squared really, plus 1, and then plus 1 outside of here. I'm going to distribute the negative. All right, so I'm going to get negative x squared plus 2x minus 1 plus 1. Those guys are going to cancel because they're like terms. I am going to go ahead and distribute to make this even more simple for myself. So I'm going to get negative 2x squared plus 4x plus 2x to the third minus 4x squared. So we're going to go ahead and combine like terms, and I think we're going to be set to take our derivative with a little more ease. I don't have to do all those crazy things. All right, so I'm going to take the derivative with respect to x, so dA dx, right? dA dx. That's 6x squared minus 12x plus 4. And I need to go back and find my feasible domain, because I often do this at the end, because I need to kind of think about where are the endpoints when I do my little first derivative test. Now, there are endpoints here, because if I'm going to inscribe a rectangle above the x-axis, I can't have values over here because I'd be making a rectangle below, and same thing over here. So I'm stuck between 0 and 2. But we have to think about if we went past 1, if I drew a rectangle at 1, it would collapse down into a line. And then after that, if I had a point over here and over here, if I'm taking this point and considering this point as the x, now I am crossing over and getting negative areas. You can try a few values and see that. If I use x is 1.5, for instance, I'm going to get 2 minus 2 times 1.5 is 3, so I'm going to get a negative value for my b. So if you use values on the right-hand side of 1, you're getting negative values for area, which is clearly not what the problem is about. So we are only going up to 1 because that's where it is at a minimum. The area, I should say, is at a minimum, and because it's collapsing into a segment, a line segment. So we're only going to go to 1. Now, I'm going to find my derivative where it equals 0 because I've got my endpoints. There's nowhere my derivative doesn't exist. And I'm telling you right now, it is totally okay to put that in your calculator and find the derivative and, put that in your calculator and find the zeros, because these problems are already really long. You do not need to add more work for yourself. So solving equations is fine in your calculator. So writing the equation and then just writing the answer is, I assume you get it from your calculator somehow. You can do quadratic formula if you really like, but actually the AP exam also on the calculator portion accepts an equation and then x equals or y equals or whatever your variable is as the answer, and that is okay. So I got two answers, 0.423 and 1.577, but this is past our value, and really it's the sister point to 0.423. It's the other side of the rectangle, the coordinates of that other corner. So we're going to put 0.423 on our sign chart, and we're going to find values. I'm going to put 0.4 in, and I should get a positive value. Then I put 0.5 in, and I get a negative value. My function, my area, is increasing up until 0.42 and then decreasing thereafter. This must be a max. In fact, it's the absolute max on that range. So our x value must be 0.423. Now, that's not what it asks for. It asks for the dimensions of the rectangle. So I need to do 2 minus 2 times 0.423 and get my value, my base, and find my value for my y. And it also asks what the area is. So I'm going to calculate the x and the y. You do the same, see if you get the same answers and check them. All right, so I got 1.154 for my b by putting an x into my formula, and my y formula, remember, is my parabola formula, so that's, I wrote my work down here, and I got 0.667. So my dimensions should be base is 1.15-ish, and my height is 0.667-ish, and then it still asks for the maximum area. What is that max area? Well, do base times height, 0.667 times 1.154, and my answer for my maximum area should be 0.769 or 0.770 if you round up. AP will accept either taking off the extra decimals or truncating, they call it, or rounding appropriately. So if you round up, you should round up. I always truncate for AP because I know I can't get it wrong then. And then, of course, write your answer as a complete sentence using units. So the dimensions of the rectangle should be 1.154 units, and the height should be 0.667 units, and the area then would be 0.770 units squared to find the max area. There you go.